All right, so the last lesson talked about different functions. Now we're going to look at linear functions, okay? So a linear function is something that would have a constant rate of change. Graphically, it's pretty easy to tell if it's linear or not. If it's a straight line, it is. We can tell number one is not a straight line, so it's nonlinear. Okay, number two is a straight line, so it's linear. Nice and easy there to start off with, okay? With a table of data, it gets a little trickier. We have to make sure we have a constant rate of change, okay? So my rate of change, remember, is determined by how the x's and y's are moving. So to go from 3 to 6, so usually we do our y's on top. So 36 to 30 is minus 6. 3 to 6 on top is 3. So in order to figure out if I have a constant rate of change, I'm kind of looking at the two in unison. So negative 6 over 3 would be negative 2. So the rate of change here is negative 2, so that's good. Okay, and we want to see, does it stay the same? So 30 to 24 is minus 6. 6 to 9 is plus 3. So again, negative 6 divided by 3 is negative 2. So far, so good. 24 to 18 is minus 6. 9 to 12 is positive 3. Negative 6 divided by 3 is negative 2 again. Since all of these rates of change are the same, this is linear. Okay, let's look at number 4. So 2 to 9 is plus 7. 1 to 3 is plus 2. So remember, it's y over x, 7 over 2. Okay, let's keep going and see if it stays the same. So 9 to 20 is plus 11. 3 to 5 is plus 2. So this one would actually be 11 over 2. 7 over 2, 11 over 2, not the same. So I know this is non-linear. Okay, so graphically, straight line or not, that's nice and easy. Table of data, is it a constant rate of change or not? That one's a little tougher. With number 5, the only way you have a linear function is if you don't have any exponents on your variables. This x doesn't have an exponent on it, so this is linear. Okay, on number 6, the x is an exponent, so that's bad. That is nonlinear. Okay, all right, go ahead and pause the video. Try those bottom 6 problems, and then you can play when you're ready for me. All right, so the graphs are the easiest ones, right? We got linear because it's a straight line, non-linear because it's not a straight line. Okay, let's look at our tables of data. So 3 to 5 is plus 2. 0 to 1 is plus 1. So 2 over 1 is just 2. 5 to 7 is plus 2. 1 to 2 is plus 1. 2 over 1 is 2. So we're good so far. 7 to 9 is plus 2. 2 to 3 is plus 1. 2 over 1 is 2 again. Those are all the same. That's linear. Okay, let's look at 10. 16 to 8 is minus 8. 1 to 2 is plus 1. Negative 8 over 1 is negative 8. Okay. 8 to 4 is minus 4 this time. 2 to 3 is plus 1. Negative 4 over 1 is negative 4. So again, those are not the same. This is non-linear. Okay, and with the equations, no exponent on 11, that's linear. Number 12, exponent on the 2 right there, that's non-linear. Okay, so we have linear versus nonlinear. 3 different ways to tell from 3 different representations of data. Let's go ahead and look at page 2. Alrighty, so we have some different representations of data that we've seen a couple times so far. So our basic ones are an input-output table. The ordered pairs just have to go across from each other. Okay, so the ordered pairs just kind of go across from each other. In a mapping, it looks a lot like a table, except you use bubbles and arrows pointing from each input to output. And then hopefully at this point you guys know how to graph. Remember your x values left and right, your y values up and down. Okay, so these are representations of data. One of the hardest representations of data to get is the equation. Okay, if you're not given an equation up front. Okay, so what we want to do here is we want to figure out, is it linear once we figure out it's linear, if it is linear, then we have to make an equation for it, okay? So let's figure out if it's linear first. So we do that like we did on the last page. 17 to 12 is no, that's actually plus 5, right? And negative 4 to negative 3 is plus 1. So 5 over 1 is 5. Negative 12 to 7 is plus 5. Negative 3 to negative 2 is plus 1. So 5 over 1 is 5. Negative 7 to negative 2 is plus 5. 2 to 1 is plus 1. And again, 5 over 1 is 5. This is our constant rate of change. So we know it's linear. Okay? Once we know it's linear, we can write our equation. So remember, our equations always need to be in y equals mx plus b. This m right here is our rate of change. Okay? So since we found this 5 to be our rate of change, that's going to go in for m. So right now, we have y equals 5x. Okay? So whatever that rate of change is goes right there in for our slope. And then our y-intercept is found by just plugging in an ordered pair. So look for your favorite ordered pair out of these. I would probably pick the smallest one with the smallest numbers, negative 1, negative 2, and plug those in. So negative 1 goes in for the x. What's happening here? There we go. And negative 2 goes in for the y. So all I did was plug in what I have. Right now I have negative 2 equals negative 5. And then I'm going to have to add something over here, right? Because we have y equals mx plus b. So I'm trying to figure out what this number over here is going to be. So in order to make this true, negative 5 plus 3 would actually give me negative 2. So I bring that 3 up here, and now my equation is done. All right, let's look at another one here at 14. So we're going down 2, up 1. So negative 2 over 1 is negative 2. Down 2, up 1. So negative 2 over 1 is negative 2. Down 2, up 1. Negative 2 over 1 is negative 2. So I have a constant rate of change. This is linear. Okay? So I start off with y equals negative 2x. Right? That negative 2 goes right there. And then plus something back here that I got to figure out. Use an ordered pair. So again, I'm going to use my smallest numbers, negative 1 and 4. So 4 is y, and negative 1 is x. And I got to figure out what makes this true. So negative 2 times negative 1 is 3, so I have 4 equals, or no, sorry, 2. Negative 2 times negative 1 is positive 2, plus what? And in order to make that true, I would have to plug a 2 in there. So I bring that up to my original equation. Y equals negative 2x plus 2. Okay. All right, let's go ahead and do 15. Okay, let's check to see if it's linear or not. Looks like we're going up 3 and up 1. So that gives us a rate of change of 3. Then we're going up 3, up 1, rate of change of 3, up 3, up 1, rate of change of 3. So we have a constant rate of change of 3. So we start off with y equals 3x plus blank, right? And we got to figure out what goes in that blank. So choose an ordered pair to test with. I'm going to choose this 1, 2 up here. So that means 2 goes in for y, 1 goes in for x, and I got to figure out what goes in the blank. So just simplifying here, 3 times 1 is 3, so I have 2 equals 3 plus blank. If I'm at 3 on the right-hand side and I want to make it equal to 2, I'm going to have to subtract 1 off of it. So my rule is y equals 3x minus 1. All right, let me have you guys go ahead and pause the video, try number 17 on your own, and then you can go ahead and play the video when you want me to talk through it. All right, so first thing I need to do is check if it's linear. So 1 to 5 is up 4, 1 to 2 is up 1. So 4 over 1 is 4. Up 4, up 1. So 4 over 1 is 4. Up 4, up 1. So 4 over 1 is 4 again. So I have a constant rate of change here of 4. So I start off with y equals 4x plus blank. Choose an ordered pair. I like 1, 1. That's nice and easy. So 1 goes in for y. 1 goes in for x. I got to figure out what goes in the blank. So 4 times 1 is 4. So 1 equals 4 plus blank. Okay, to be at 4 on the right and get me down to 1 that I want to make it to make it equal, I would have to subtract 3. So y equals 4x minus 3. So those are your linear function notes.